Good afternoon. My name is Anna Roberts, and I'm a researcher at the Adam Mickiewicz University in Poland. And today I'd like to talk to you about my studies of sociality and communication in chimpanzees. So chimpanzees have differentiated social relationships, which means that they don't invest equally in their social interactions, but have preferred social partners. And it was suggested that this reflects time and cognitive demands on social relationships. In order to bond with others, we need to track social relationship with our partner, and we have a limit on how many relationships we can keep track of. There's also a time constraint on social relationships. We need to invest time to maintain our bonds. So these time and cognitive constraints are particularly important in more complex social settings, such as larger social groups. So in larger social groups, we would expect to have more differentiated relationships and larger number of weaker social bonds. So the question is, what is the strategy that chimpanzees use to be able to maintain these weaker social bonds? And one mechanism is use of gestural communication, and particularly complex gestural communication that involves, for instance, use of object or manual gesture. Such communication can reduce uncertainty of the recipient, allow them to infer goals and intention of the signaler more effectively. And I'd like to show you one example of such communication here. So here a female chimpanzee uses manual gesture to incite her baby to approach. Social bonds have adaptive advantage because strongly bonded diet partners have lower stress than weakly bonded diet partners. And stress can be assessed by looking at displacement activities such as scratch. So we would expect to find that if gestures have adaptive advantage for social bonding in chimpanzees, then we would expect to see the link between gestural communication, social behavior, and scratch. So today I'd like to talk to you about some findings on that link, that on this relationship. So to examine this, I studied 12 focal chimpanzees in Uganda, in Budongo Forest. I recorded continuous footage of gestural communication and scratch. I simultaneously collected focal data on context, so I recorded identity of the nearest neighbor, their proximity to the focal subject, and also the identity of all of the individuals who were present within 10 meters. And there are many different ways to assess a presence of social bond between chimpanzee dyads. And one of those ways is to use a duration of time spent in joint activities. So in this case, I used joint feeding, resting, travel, grooming, visual attention present and absent, and proximity. I added rates of these different behaviors and divided the sum by the number of the social networks. So this gave me a weighted composite sociality index, and you can see in this graph here the arrow indicates the direction of the relationship, and the thickness of the arrow, and the line indicates the rate. So in this case here, NK had the higher rate of interaction with BB. So NK is the dominant male, and he directed more of his social behavior towards the beta male Boba. I also collated a gestural communication network, so number of gestures that focal directed at non-focal chimpanzee per hour they spent within 10 meters. And I had two different social communication network, complex gestures that included use of manual movement, gestures accompanied by use of facial expression or vocalization, that incorporated use of objects such as leaf of a tree, gestures that were combined simultaneously or sequentially, and all other gestures which were non-complex gestures. And here I only consider gestures that were used to initiate activity change. Scratch network was the network where I looked at the number of times chimpanzee scratched in presence of another individual per hour when another individual was within 10 meters, and per hour they spent within 10 meters. And all these three weighted networks allow me to calculate the centrality measure, normalized degree centrality. So in this centrality measure, there's in degree, which is the average value of social behavior received by the focal chimpanzee from all other chimpanzees in the network. And there's an out degree, which is the average value of social behavior produced by the focal chimpanzee towards all other chimpanzees in the network. So first, I used generalized linear model to predict a social bond. I was interested in looking at whether chimpanzees adjusted use of communication to the social bond they had with the partner. And I found that chimpanzees directed more complex gestures to initiate activity towards partners with whom they spent shorter duration of time in social activities. I then used social network analysis to examine predictors of centrality in the social networks. So central chimpanzees were those who had a higher rate of social behavior directed at a larger number of social partners. And I found that those central chimpanzees produced non-complex communication at a higher rate, which suggests that they communicated mostly with the stronger social bonds, but they received complex communication at higher rate and scratch at a higher rate, which suggests that they were a target of social bonding from a larger number of weaker links. I then looked at the predictors of centrality in the scratch network. So central chimpanzees in this network were those who scratched more in presence of a larger number of social partners. And I found that those chimpanzees who were central in the scratch network produced complex gestures at lower rate, but received non-complex communication also at a lower rate. So this would mean that they were less communicative with weakly bonded partners, but also received less communication from stronger bonds. So they were less integrated in the network. So the conclusion of this research is that complex communication has adaptive advantage by increasing social bonding and reducing stress. And I'd like to thank these organizations for supporting my research.